If you've got a question, the voices of resin are here. Oh, PlastChicks.
PlastChicks is an SPE sponsored podcast.
Hey, Lynzie, how's it going?
I am just great. It's opening season for the NFL. Today, the Bills play LA. And I'm very excited. If you can't tell, I'm all decked out in all my Bills gear. My kids
So
are decked out.
what Allentown, I know there's like a Billy Joel song.
Yes, that's what it's referring to. It's very meta if you think about it. It has nothing to do with Josh Allen, the Bills quarterback.
Oh, right. I think you've explained this to me before when it was a football time. Yeah.
Yes.
Yeah.
We are back in the football
I always
time.
get very excited. I made a shortcut on Siri. Hey Siri, Billy Joel me, please. I don't want to do it, but then it plays hopefully it does. Oh gosh, it's gonna do it. But it plays My Life. Congratulations on your Allentown Buffalo Bills opening season day.
It is a very good day.
And that's not at all what we're going to be talking about.
No, this is not the PlastChicks take on the NFL, although maybe someday, you never know. For those of you listening at home, I'm Lynzie Nebel, and I am an upstream product quote engineer for Cytiva.
There we go. It's about lunchtime for us. Yeah, so I haven't eaten yet. I don't know if you have either, but maybe we're firing a little bit slower in the middle of the workday. I'm Mercedes Landazuri. I am Director of Technology and Innovation for Peacock Colors and Vortex Liquid Colors and Polycompounding. We're both involved in SPE, Inspiring Plastics Professionals, Society of Plastics Engineers. I don't know why I said it like that order, but
I like that.
I'm on Color and Appearance Division and Recycling Division and Chicago section, and Lynzie is a big deal.
Yes, a big deal to my children. And I'm on the injection molding division. I am also on the executive board as the vice president of member engagement. But with our powers combined, we are PlastChicks.
PlastChicks.
Mercedes is just staring at me.
The voices,
like we have never done this. Day one.
Listen, it's very hard to do when there's a lag. Yeah, we're two people who work in the plastics industry, and we met and fell deeply into friend love, and decided to start a podcast to spread the good word about our industry and people in it, and all kinds of innovations, materials, processes. I mean, we could go on, and we often do.
And we do.
Yeah,
always do. You can listen to our podcast on Spotify, Apple Podcasts, Google Podcasts. Basically, if you can get a podcast, we're probably there. But also, if you want to see the video version of this, where Mercedes just stares at me when we say our tagline, instead of doing the tagline like she always does.
There's a lag. There's a lag.
There's a YouTube version of this that goes up usually about a week or two later after the episode itself comes out. And we're also on social media, all the social medias except for TikTok, even though we keep saying we're going to do one, and maybe eventually we'll get one just as TikTok itself.
Right. Well, didn't you create a TikTok for us, or like you were excited about it, and then
I have the tag or the username, but there is nothing on it.
Well, I mean, that was like how we started our podcast. We came up with a name.
Name first, content later. That's all that matters.
I still really love Good Morning Amorphous Materials. I think that we're going to have to do some kind of like morning show at some point.
Maybe.
Well, I mean, you're waking up early these days. But enough about us. Hello, we haven't forgotten about you, Patrick. So this is thanks so much for joining us today. This is Pat Haney, Research and Development Engineer at MTD Micromolding.
Yeah, hello. First podcast I've ever done, so excited about it, and it's also first time hearing about Lynzie's TikTok. So I'm kind of probably scared of that. Yeah,
it's the first time a lot of people are hearing from the TikTok. Yeah. So, Pat, tell us a little bit about yourself. Tell us a little bit about MTD. Let's get the intro stuff taken care of.
Yeah, that's the hard part, right? Sure. So I went to Penn State Behrend originally when I started my plastics career for plastics engineering. And after stepping through that program, I think I started that program in 2012. And stepping through that program, I decided to take the co-op route. And when I was an upperclassman, I went to New England, to Vermont, to Husky for a little while, and eventually found my way to Massachusetts to MTD Micromolding. So through that career path, started to take an interest in research and development more and more. And I think my energy and my personality and my interest married very well with MTD, and we ended up getting a good relationship. So I actually,
knowing you personally, you are a curious son of a gun.
Yeah, that's an interesting way to put it. Yeah. Lots of big personality, some people might say sometimes, but so yeah, got a good relationship with MTD out of the gate there, and ended up signing a job before I even graduated. So the first official internal research and development project for MTD also identified as my senior project in college. So you can kind of think of me at the time as a liaison between Penn State Behrend and MTD. So we started to do a lot of micromolding R&D because we noticed that there's a lot of crazy phenomena that happens in micromolding. And, fast forward to 2022 now, and I'm doing it full time out here at MTD, and it's a great time. It's a super unique environment and position. I don't know of any other ones like it. And I think that's why I like it so much.
Mm-hmm.
Yeah.
So why is it, how is it unique? How is it different?
Well, I think first and foremost, MTD is a CDM, right? Or a contract manufacturer. So usually those companies, are just hired to make the products of other larger OEMs. And they kind of do a job and do it well, and then that's that. But for a CDM to have internal research and development, the question is, or the question that crops up is, what does that even mean? For a CDM, what do you have to develop and research as opposed to just doing jobs? And it's unique because we're a CDM, but it's basically a non-direct revenue generating position, and it's basically an entire branch of engineering that the company invests in quite a bit in. I think it's somewhere at least 10% a year into internal research and development, because all sorts of things go crazy when you go super small. Non-Newtonian fluids basically stop acting like non-Newtonian fluids should act, or how we expect them to act. So shear thinning's different, crystalline formation's different. The list goes on, and because of that, there's a lot of crazy things that end up happening, crazy phenomena that happen where you go, okay, well, that shouldn't happen. Nobody expected that to happen, but it happens all the time. So essentially my job in a large capacity is to understand that phenomena and either figure out how to control it or understand it or prevent it, whatever it might be, so that plastics become predictable and manageable again. Right. So, yeah.
And, MTD takes it one step farther, where you're not just doing micro, but you're doing micro medical. So,
Correct.
what kind of extra, restraints does that put on you guys as molders to have to fall into both those very strict categories?
Oh my goodness.
Yeah. I mean, I think when it comes, so not only do we are 100% medical first of all, but beyond that, I think it's something around 80% of the stuff that we make are implantables. So there's pretty much the strictest criteria that you can possibly have on plastics injection molding, in terms of, not only does it have to fit the drawing, but you start getting concerned with like what happens if the residual monomer count is too high in the molded product, because you end up having like very reactive compounds that are going to be implanted in the soft tissue, so that could be an issue. So I guess that's, again, we're kind of elaborating on why the position is unique and why it's also needed to be, successful to the degree that we are. So, not only do we have the molding presses, but we build all our molds here. we do all the molding here and the metrology here, but we have a bunch of analytical characterization stuff too. So, we do DSE testing here. We have gas chromatography capabilities. We have CT scanners. We do intrinsic viscosity testing. So we monitor molecular weight loss throughout all these things where we can not only use conventional metrology to analyze part, quote unquote, part quality, but we can also basically analyze the polymer matrix too, because the preservation of the material is so severe to the application that it needs to do, right?
Yeah. And, so, you're talking about all these extra things you have to do within, just regular molding. Whereas, there's some places where you literally just get to dump material, press the button. And even if the process isn't quite the same, you're probably going to be fine.
Mhm. Yeah, flower pots, right?
Making color
Right.
chips.
Like making color chips, for example. What, you talked about your position kind of being unique and, it being a branch of the company that's not necessarily like directly tied into the active projects, like the active customer projects that are going on. What is like an example of what you do in a day? Like what kind of stuff comes across your plate? Where do you spend your time besides lunch?
Well,
Which
food
is
is
only 15 minutes on.
food is
Yeah.
a big part of it. Ask some people here. There's probably every 2 hours, there's always something I have in the fridge or something. But the day to day is interesting because it varies like crazy. Sometimes I'll go weeks and weeks where, I'm doing. I will be working on a customer project, but that doesn't mean that every new project is going to cross my desk. The ones that do, again, there's some kind of bizarre phenomena, like I'm making up a hypothetical, but it could be, well, we have a polycarbonate piece that is 4/1000 wall thickness and, a centimeter long or something, so how do we fill that, by the way, there's a core pin in the middle of it, so crazy things like that. That's just an example. But if anything gets to the point where we go, well, maybe we can do it, but we've never quite done anything like that before, and neither's anybody else. So instead of putting it through process development, that's going to go to R&D through this prototyping phase instead. And there's this is actually something new that MTD's started to crank out the last few months to a year, is different prototyping pipeline for projects that makes sense to put through. So sometimes I do work on customer projects, but those projects are they're bizarre for some reason, and then the ultimate goal is to eventually hand that off to regular process development, because we want to see success. So sometimes there's things like that going on. Other times, if things are maybe a little bit slower on the prototyping customer project front, I will, there's a whole laundry list of weird phenomena that we've observed in the past. And if I have some free time, sometimes I spend a lot of time researching that, a lot of time on Google Scholar, a lot of time talking on the phone with, resin experts or polymer chemists at a resin supplier or something, trying to wrap my head around weird things that we see. Sometimes it's a lot of discussions with customers before maybe they be in the design phase and they don't know, what material to use or what's necessary and what's not necessary for what their application is going to demand. So I do interface a lot with customers in that capacity too, where I can do a lot of work with sales and account managing and things like that to make sure that we are going to give the customer what they need on the front end before anything gets kicked off. So there's the least amount of backtracking in the prototyping phase, So beyond that, conferences, I go to a lot of conferences, give a lot of talks. So usually when it's trade show season, I can be, jumping around on an airplane every once in a while. So it's pretty dynamic. It can change. And I think that's one of the things I like about it the most, to be honest.
And you get to work with quite a lot of materials, right? A pretty wide variety.
Mm-hmm.
I saw that you had really interesting. So you won first place in the engineering division Baron for it is in 14 with exploring coconut shell reinforced polypropylene and olefin blends.
Right. Yeah. Yeah. I forgot about that actually. That's funny you brought that up. I
You're
haven't thought about
welcome.
the coconut project in a long time. Yeah. I
Mercedes
remember
does a deep dive.
yeah. I remember that the lab supervisor walked over because it smelled so good because we put
Mhm.
coconut oil in it. We used coconut oil as a plasticizer for that.
Oh, nice.
And I remember we ended up lowering the glass transition like a full 10 degrees Celsius just with coconut oil and like
Wow.
turkey pans, like mixing it in turkey pans and before we put it in the hopper. And it smelled like Oreos for some bizarre reason. I don't know
Not
why.
mad about that.
No, and I remember the shop supervisor ate a pellet. She was like, "Oh, what is this like?" And we were like, "It's polypropylene. You probably shouldn't eat that." But,
It's not her
But
first
let's be real,
pellet she's
everybody
eating.
chews on pellets. Everybody chews on pellets. If you're,
Especially polypropylene. If you're gonna
Yeah.
go,
yeah,
pick a polypro,
yeah.
like
So
glass filled nylon. Then we gotta talk.
yeah,
Yeah.
yeah. It's like chewing on some fiberglass. Yeah.
Right.
I think, yeah. Well, I guess with that in mind, like that's probably where my original interest in, polymer science research and development came into play, right? Because there was a lot of projects in college and in school where I was playing around with additives or trying to nucleate crystallinity with something, whether it be a processing method or something like that. So there was a lot of additives and compounding because in college we had the luxury of like extruding and pelletizing our own stuff, and then we could try to mold it later. So we had kind of the full spectrum of capability in that sense. So after we do that, and we do mechanical testing on them, and we do DMA and DSC and all this crazy Doc Brown stuff. So like that translated to, I mentioned the first R&D project I did for MTD while I was still in school. MTD works with a lot of bioabsorbables, right? So that's a huge vein of what we do. And those are biocompatible materials that are basically chemically engineered to dissolve or disassociate at the rate of tissue regeneration. So they're implanted into the body and perform some kind of function and then basically just break down into like lactic acid or something, something that your body just kind of incorporates and absorbs. So, instead of polypropylene and coconut shell fibers, it transitioned into bioabsorbables, PLAs, PLGs, lactide glycolide stuff. And can we nucleate those things with like hydroxyapatite? That's what the project was. It was synthetic bone dust is basically what that is, trying to speed up the slow crystallization process of PLA in that sense. So, yeah, that's where the R&D kind of interest started, and it was a great fit for MTD. So, like I said, MTD does a lot of bioabsorbable stuff in terms of all the materials we work with: lactides, glycolides, caprolactones, polydioxanones,
all your
ethylene
basics.
glycols, yeah, all the basics. Really. Yeah. So those materials are bizarre in and of themselves because they're literally made and polymerized to degrade. So they're very prone to oxidation. They're very prone to hydrolysis. They're meant to be, right? So it's not really a failure of the material. It's really a success of the material that they are that way. So the question becomes, how do you take a material like that is prone to degradation and is meant to degrade and, expose it to the highest shear rates in injection molding, and how do you do that and preserve material integrity, right? So yeah, it's very specialized. It's a very specialized technique with very specialized materials, but with that being said, I will add there's other materials that we use too, like the more common ones, the commodity plastics, engineering plastics, all the way to high performance. We do a lot of PEEK because PEEK is super popular for permanent implants that aren't meant to dissolve, PEIs, all that kind of stuff. So really the only thing we don't touch, I think, would be like silicone, because that's just completely different. LSR is just completely different hardware. And we don't do a lot of PVC because when you shear that, it releases hydrochloric acid, and let's say you have a 5,000 skate diameter, for example, right? It doesn't take very long for hydrochloric outgassing to eat away at, a 5,000 hole that's popped in a steel plate, so it's very corrosive and it's very difficult to deal with. But luckily there's other medical alternatives to that material. So, yeah.
Well, we're kind of talking a lot about like the different polymers and like what their, benefits, non-benefits, all that kind of stuff, and how they are a big part of micromolding. But the other side of that is your tooling. What kind of adjustments do you need to make in your tooling for micromolding? And slap it on a fancy and call it a day?
No, I think tooling is probably arguably the most important part of the whole thing. I think I tend to talk about the plastic a lot because that's the world that I live in, but we are, top down. So we have our own machine shop here that has a whole smattering of capabilities. That it all starts there. If we didn't build the tools in-house, I don't think we would have the success that we have. Because those guys back there, it's funny because I've said to new employees and stuff when they start here, I said, we're all just regular people, right? We're all really kind of quirky in one way or the other, but we're all really good at what we do, and everybody has different specialities, So we have a huge machine shop. We actually just doubled the size of the building. We built an addition in the last few years, believe it or not, during like the height of COVID, we were building an expansion. Yeah. Right. So we about doubled the size of, I want to say, somebody's going to yell at me for this later. I'll probably get it wrong. I think it's a 2,400 square foot addition, I think. So the old machine shops converting back into new clean rooms. And then the addition encompasses all kinds of things: wire EDMs, sinker EDMs. We have technology that cuts it with a single electrode. And some more conventional means of, CNC and milling and those kinds of things. But the entire mold base, right down to the inserts and the cavity geometries, the runner system, all that stuff is designed here at MTD. It's, the engineers and the processors interface with the mold design engineers all the time. So it's a really kind of well-oiled machine. Once you live in an environment like this, you start to realize that everything is kind of this ball of yarn. Everything's kind of attached because the tooling is driven by the plastic and the shrinkage, but the molding is driven by the tooling, and it's all very, everything needs everybody.
Right. So I imagine then everybody works really collaboratively then.
Yeah, it's probably one of the that's the other reason why I like MTD so much, is because I think we're only, at 40 some employees. We're pretty small, relatively speaking, but it's still kind of that family environment sort of thing. We all get along really well. And that's like so important, that we can be honest about our feedback, or, everybody's got this open door policy. So if you have a concern about something, or you're thinking about something, or you're stumped, it's not very hard to find the resource that you need to solve that problem, or even just bounce ideas off of. Yeah, it's a fantastic environment. I think
open door, unless you're recording a podcast.
Yeah. I have a sign on the door right now. It's taped, and I wrote on Sharpie in big bold letters, "Don't bother me." That's all it says.
And someone's going to be like, he's fine, I can bother him.
Right. They're tapping on the glass.
Just like,
Right.
yeah.
So now, we did touch on this right before we started recording, but now tell me how you guys met.
Well, I was going to say, I mean, we know each other through the
How you know each other
program. Because obviously it's a small enough program that, you kind of know names of people above you, names of people below you. And we did overlap a short time at MTD before Pat stayed, and I did not. And now he's just doing all the things.
So question for you, Pat, has Brian Young ever made you cry?
Always.
No, he did. This is probably going to get him in trouble. He did hit me in the He did hit me in the shin with a wrench once though.
That sounds on brand.
Yeah. I was in the molding shop in the lab, and I was a college kid, man. I had steel toes from Walmart on, right? Like,
Yeah.
because they're like $30. And
you were at least wearing steel toe, because I don't think my class. did that.
well, yeah, I mean, it got to the point where they were like, hey, if you walk in here without toe protectors on your steel toes, we're gonna fail you, like, at a senior project. And we were like, okay, well, I always thought it was a little extreme, but whatever.
Good habit. Good
Yeah.
habit.
So I had these like Walmart steel toes on, because if you put the toe caps on, you sound like this like horse,
A little horse.
Yeah, like actually though. So I was like, whatever, I'm just gonna wear these $30 boots. But they didn't look like steel toes because they weren't Chippewas or
Right.
whatever else. So he didn't think they were steel toes. He was like, Haney, are those steel toes? And I was like, yeah, they're steel toes. And he's like, are you sure? And he like picks up a wrench, and I'm just like, yeah, I'm sure. And he threw it, and he meant to hit, like it was going to bounce off the toe, right?
Oh no.
If I was telling the truth, I would have been fine. But he must not be a very good athlete, because he hit me right in the shin instead. And he probably doesn't even remember it.
I was gonna say,
He's like,
and
oh! Yeah.
And I was gonna say, don't worry, he probably doesn't even listen.
No, yeah, that too. Yeah. I'll tell him to
love
listen
that.
to this one.
I love a good Brian Young story. Absolutely.
Yeah.
love it.
Yeah, there's a bunch of them, but he was
Oh.
I got him as a grader too, and when my senior project. So that's like the worst case scenario,
That is the
as an undergrad plastic student there, because he was by far the strictest grader on it, But
Oh,
if
100%.
if I'm not mistaken, I believe we ended up getting a 98 on that project. So it all panned out in the end, I guess. Yeah. But,
All worked out. He's probably making
yeah.
up some points for that wrench throw.
yeah,
Brad?
maybe. Yeah. So-
So going back to some of the stuff you're doing now, because I know we're kind of running short on time. What's, tell us, I know you can't tell us all the things, but what are some of the coolest things you've worked on, or like worked on in the past, or maybe are working on now, that
Yeah.
are not coconut?
Yeah.
Right, not coconut shells. Yeah, I mean, that question can go all sorts of different directions, because there's so many cool things that we've done over the years here. But I think maybe like a couple of cool examples are like, we really started to notice that if we talk about if for those of us listeners that know how an injection speed is optimized in a molding process, right? You basically are gathering cavity pressure data and fill time data and things like that, and plotting a chart, and then watching. The effort is to watch when the viscosity isn't affected by changing shear rate so much, right? Because you want to the buzzword is accommodate for material variation, right? It's forever burned into my brain from that school. But yeah, so we notice that viscosity behavior doesn't act the same when we are micromolding. And throughout, I've done a lot of talks on this too at different trade shows and things. Yeah, I talked about it. I did. I think I have talked about it at Antec, I think, but maybe. But we noticed that there's a point where like things act like water, they act Newtonian, and then they should start to act non-Newtonian and shear thin. But then you reach a point, and it is actually possible, believe it or not, where all the polymers are oriented in the same direction. All of them. There's no entanglement during flow. And when that happens, fountain flow and non-Newtonian characteristics they start acting Newtonian again, So that realization.
You take your book that from Penn State, light it on fire.
Yeah. It's just like all these conventional tools
Right.
that macro molders use aren't applicable here. So we also found out that when you get to that degree, the crystalline structures change because the nucleation sites change, right? So we basically, in other words, find out that, okay, so this stuff doesn't flow the way that we expected it to flow, and it doesn't set up the way that we expect it to set up, So there's a complete revamp on how we change our processing methods, and how do we optimize the process now, because all the regular industry tools aren't quite cutting it, so kind of being the thought leaders and the spearheaders of that, at least in a practical sense, because there's plenty of academics that already knew that stuff happened, right? It's the activity of marrying like practical manufacturing and industry with like theoretical academia, because they have a lot of great knowledge.
And I love that because I feel
Yeah.
like that is a big gap in our industry.
Oh yeah.
Right. Yeah, we've been talking about it every Saturday.
Yeah. I mean, there's so much, academic knowledge and, knowledge in the theoretical level, and the application of it in, your manufacturers, your general manufacturers. Sometimes
Mhm.
that is just like, that's not even like a little creek you got to jump over. That is like a gorge,
Right. Yeah.
big as the one
Yeah.
behind Barron where we all used to party.
I like that you just said crick, because everybody out here makes fun of me for saying crick, because it's supposed to be creek.
As I said it, I felt
Yeah,
the
That's
Pennsylvania.
awesome. No, it's great. I love it when other people say it. It's great.
Where do they talk like that? Is that like a Buffalo thing or what? Who says
It's
No.
more, I think it's more Pennsylvania. I don't think-
Western Pennsylvania.
yeah,
right.
That's not something I inherently grew up with.
Yeah. It's like I was talking about
Spewed out of me.
getting my oil changed in my car. I have oil,
Oil.
but people are like, "What do you want to do?" Because I'm like, I gotta get my oil changed. Oil changed. Anyway, yeah. So that's kind of my main personal, I guess, maybe career goal, is to find ways to marry academia, or at least the theoretical world, not necessarily academia, but the theoretical world with practical manufacturing, because they have different motivations, and because of that, they don't communicate very often. Which is curious, because you'd think the research should be applied at some point, right? So we've actually done things in the past. We don't have any people on the payroll to do this right now, but we had a physicist on staff for a while, actually. And the whole point was to, okay, well, how can we take somebody that is very well versed and technical minded in theory, right? And then we can give them the practical tools of plastics. And we got some really cool things that came out of that. Like we have methods now where if we have crazy undercuts in a part or something like that, we have mathematical models that can tell us, is there a way that we can step the parting line or something like that to optimize the way the tool build has to be, so that we can make this as cheap and effective and robust as possible, right? So like a lot of really cool things like that, where you kind of go, okay, well, is there research out there, or can we just solve this problem with just pure math or something?
Mm.
Um,
Or coconut oil.
Or coconut
or
oil.
coconut oil in a turkey pan. Yeah.
Now, now you're bridging the gap one micromold at a time.
All right. Oh, that's so cute.
I was just saving that.
No, they're so adorable. They're so adorable. I got a chance to see. Gosh, yeah. I love getting on the floor whenever I can on the shop floor, and I really love small things. I guess that's all I have to say about that.
That's all I have to say.
Well,
And
Diversity.
as part of like, maybe not a direct result of your project, but I know they just installed a Sodic over at Barron's yesterday.
Oh, yeah?
Wednesday, something like that.
Right.
So,
Hmm.
change is slow, but look at it go.
Right. Yeah. I remember that being I was advocating for that quite a bit, right? Because that's another thing.
So cool.
MTD doesn't mold with conventional reciprocating screws. The injection units aren't normal, right? There's over under things that use screws and plungers and junctions and things, and it's all for repeatability and precision, because our cushion isn't our cushions are measured in millimeters, not inches or something. So you need that extra level of precision. So Sodics are fantastic for that. Absolutely.
Well, if Sodic doesn't promote this episode, then
Mhm.
we're gonna
Oh,
be
we're doing that.
long.
Are we doing the ads? We're gonna break for
we're
the
gonna
ads.
have to. This is where we call up Sodic. Just so you know, you purchased an ad unknowingly.
Yeah. Right.
I feel like I like Kohan and Len would be down for that.
Oh, 100%. They'll be fine.
It's sometime.
Right.
Yeah.
They probably would.
Probably would.
Yeah.
Oh, God bless them. All right. Well, I think we are just about out of time.
Yeah, we all gotta
Um,
go back to work, and you gotta go tell Danny that he can talk again.
Oh yeah, I do have my husband being on quiet notice in the corner. Well, Pat, it's awesome to talk to you. Always good to hear all the cool stuff that's going on at MTD. And we love the cool stuff you're doing and all the gap bridging. There we go. It's fine. Yeah.
Wonderful.
So-
Yeah,
Yeah, awesome.
I learned so much. There was Lynzie. Why didn't you tell me any of this stuff before?
Oh, I like to keep things a secret.
typical.
That's
Right.
me. All right. Well, thanks so much.
All right, guys, that was fun.